This is an addendum to our Plato's Cave meeting in September last year. It was on mind transfer, a measure of man. At the time, I had discussed the possibilities of memory being chemically based rather than just an electric state. The discussion entailed about things about the experiments done with planaria, flatworms. I'm going to read part of an article written by Isaac Asimov. The original article was called What's on Your Mind, and it appeared in the May 1972 issue of Penthouse. He calls it in this book Life and Time. The name of the article is Forget Me Not. There is an important difference between a circuit representing a memory bit and a molecule representing it. A circuit is not a material thing so much as a relationship among cells. It cannot be transferred unless a group of cells is taken out alive and replanted alive in another brain. A molecule, on the other hand, is a material thing and a non-living one at that. It might well be taken out of one organism and injected into another. And yet, just to make things more difficult, isn't it possible that each organism invents a protein or a circuit for itself every time it needs to store a bit of memory? In that case, transfer is impossible because each brain would have its own language that would be gibberish to any other. Still, scientists were bound to experiment. In 1961, James B. McConnell at the University of Michigan reported startling experiments with small organisms called planaria, which are very low in the scale of life complexity. He subjected them to a flash of light and then to an electric shock. Their bodies contracted at the shock and eventually began to contract as soon as the light shone. They had learned that the light meant a coming shock, and that might mean the production of special memory molecules. McConnell then chopped up the trained planaria and fed them to untrained planaria. He found that the untrained planaria, after their cannibalistic diet, learned to react to the light faster than ordinary planaria did. Had they incorporated some of the special memory molecules and obtained a head start? It was difficult to work with planaria, however, and to interpret their behavior. Not everyone accepted McConnell's results. In 1965, the Danish physiologist Ingjerd Frusenstad moved much further up the scale and began to work with rats. He trained rats to go to the light in order to get food. He then collected their brains of a number of such trained rats, mashed them up, and injected the material into untrained rats. He found that such injected rats learned to go to light very quickly. Somehow a memory of light-associated food had been transferred with the brain material. The Hungarian-American physiologist George Unger went even further. In 1970, he subjected rats to an electrical shock in the dark so that they finally developed a strong fear of the dark. Brain extracts, when injected into unshocked animals, cause them to show fear of the dark too. From several pounds of brains from animals trained to show fear, Unger isolated a chemical compound which would induce the fear in untrained rat. What's more, it induced the fear in mice too, and even in goldfish. Not only were the memory molecules in one organism not gibberish to another organism of the same species, they were not gibberish even to organisms of another species. Unger called his compound scatophorbin.